What do we know so far about finding sides and angles of triangles? We know for a right triangle that we can use the Pythagorean theorem and SOHCAHTOA. Don't forget that even though we are working with oblique or non-right triangles right now, if you see a right triangle, you can still use the Pythagorean theorem and SOHCAHTOA. Don't think that you have to use law of sines and law of cosines for everything, because you don't. Right triangles are still right triangles, and you can still do the short, simple way for right triangles. Now for oblique triangles, which means non-right triangles, of course, then we can't use Pythagorean theorem or SOHCAHTOA. We can use the law of sines and the law of cosines to find missing sides and angles. For the law of sines, there are certain triangles that we should use, and for the law of cosines, certain triangles. So if we know two angles, in other words, an angle side angle or an angle angle side, use law of sines. If we know two or more sides, side, 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 or side angle side, we're going to use law of cosines. Now it turns out there's one other situation where we use law of cosines, and that is side, side, angle. Or you could write it angle, side, side, and that might be a way to think about it, because this is the bad triangle. This is the one that is going to cause you extra work and extra problems. So let's look at the first example of this. We're given triangle PQR with one angle, so this is angle Q, is equal to 20 degrees. Side P is 10 centimeters, and side Q is 5 centimeters, and we're supposed to find side R. This dotted line is where side R will be, but we don't know how long it is yet, so right now I just made it a dotted line to give us a side for this angle, but I don't know how long it will be. Side Q needs to be drawn in, so what I'm going to do is just kind of use this little ruler here. So this ruler is 10 centimeters long for side P, and then I marked a 5 on here, so I'm going to kind of angle this so that I can draw a side of 5 units long. I'm going to have to angle a little bit more, let's see, so that this just will touch R. There we go, that looks pretty good. So here is a side of length 5. Okay. So 5 centimeters for side Q. And I'll kind of get this out of the way for right now. We'll use it later for some other problem. Now I want to find the length of side R, which I'll mark with blue here. Okay, and this is my angle P right here. Now the way we've done this in the past is that we have said, okay, we want to find side R, so we'll do R squared equals P squared plus Q squared minus 2PQ cosine of R. But we can't use this because we don't know angle R and we don't know side R, so we have too many unknown pieces of information. So I'm crossing that out. That is not what we're going to use. What we are going to use is the version of law of cosines that has angle Q in it, because that's the angle we know. So we're going to write it this way. Q squared, use blue here, Q squared equals P squared plus R squared minus 2PR cosine Q. Because now I can fill in everything except for R. I know all of the other pieces of information. So for Q, I have 5 squared here, P squared, 10 squared, plus R squared minus 2 times 10 times R times cosine of 20. So the only thing I don't know is R. But the difference between the ones we've done before and this one is that I have an R squared and an R in my equation, making this a quadratic equation. So you're going to have to remember something about a quadratic equation. You're going to have to remember that to solve it, we're going to need the quadratic formula. So here's the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you sing that, you'll remember it. Now where do a, b, and c come from? A, B, and C come from the quadratic equation written in standard form like this. Ax squared plus bx plus c equals 0. So I need to write my equation with the squared term first, then the unsquared, then the constant equal to 0, so I can identify A, B, and C to put in the quadratic formula. So over here, I'm going to start by subtracting 5 squared from both sides, so I get 0 on one side of the equation. Then I'm going to rearrange, so my r squared term is first, r squared, and here is my r term right here. It's all, but it's kind of in a weird order, so I'm going to multiply the 2 and the 10 together to get 20, and I'm going to have minus 20 cosine 20 times r. So minus 20 cosine of 20 degrees r. So all of this is being multiplied times r. And then 10 squared minus 5 squared is 100 minus 25, so plus 75 for my constant. So now I've identified A. A is the coefficient of r squared. Since there is no number in front of that, the coefficient is 1. B is the coefficient of r, negative 20 cosine of 20. C is the constant, 75. Now I need to put this into the quadratic formula, but this B term is a real mess, and if you try to fill it in for here and here, it causes all kinds of careless errors. So I'm going to show you a better way to do this on the calculator. So what we're going to do is use the store feature. So you need to pull out your calculator, pause the video and pull out your calculator and do this along with me right now if you don't already have your calculator out. Okay, hopefully you have your calculator out now. You are going to type in the number we're using for A, which is 1, and then you're going to go to Control Variable. Notice the STO above that. This allows us to store a number to a variable, and then push A and enter. Now if I type A now, notice it is in bold, and if I push enter, it evaluates it as 1. Now I'm going to do the same thing for B. I'm going to use the negative sign, the negation sign next to enter, not the subtraction sign. So negative 20 cosine of 20. Make sure you right arrow to get your cursor out of the parentheses, and then Control Variable to get the store, and then B, and push enter. And then our last one is 75, Control Store C. So now when I type in A, B, and C on my calculator, the calculator will recognize those three variables with the numbers that I have stored inside them. So now all I have to do is type in the quadratic formula. So I'm going to do Control Division to open up a division template. Then type in negative B, remember using the negation sign, negative B. Notice it comes out as a bold letter, which means it has a value stored to it, plus the square root of b squared minus 4 times a times c. Now I'm going to back up for just a second. If I just typed in 4ac without times in between, notice they're not bold. The calculator recognizes this as a different variable name, a variable ac. So I have to put times c, and notice they're both bold now. And then down here, 2a. So all of my variables are in bold print, which means they're all going to evaluate for a particular number. You're going to do a Control Enter, and there is one of the sides of the triangle. Okay, there's side R. However, there's another solution when you do a quadratic equation. There's minus the square root. So up arrow until your quadratic formula is highlighted, push Enter to copy it, and then left arrow until you get to the right of the plus sign, use your delete button, and then put a minus sign, not a negation sign, a minus sign, and do another Control Enter, and I got a second solution. Okay, so I have two possible solutions here for R, so what does this mean? Let's write these down and take a look at this triangle here. So we have R equals 13.04 or 5.75 centimeters. Why did we get two solutions? When you look at the triangle, you can tell that this big long blue side must be the 13.04. 5.75 does not make sense for that side. 13.04. So that is the long side. But let's take a look with our little ruler again. I tilted my ruler this way, but what if I tilted my ruler a different way? What if I tilted it this way? And I took that 5 and let's get it kind of rotated a little bit more. Just a hair more. Oops, probably not quite that much. So this is a little tricky here. Oops. I think this will about do it. There we go. Notice that I could have also drawn the side right here. So I end up with 2 possible triangles. One triangle, I'll kind of go over it in blue, is this big triangle right here. It has an angle 20, a side 10, and a side 5, and its third side is 13.04. But then I also have this red triangle here. It also has an angle 20, a side 10, and a side 5, but its third side is 5.75 centimeters. So notice we don't have just one possible triangle. There are 2 possible triangles because I have 2 possible positive solutions. This is why a side-side angle triangle sometimes gives us issues, because and that's why it's called the ambiguous case, because there could be 2 possible triangles. Now there aren't always 2 possible triangles, so in the next video we're going to look at the other possible things that could happen with a side-side angle triangle.